Grey Fire pupils, a few examples of completing the square for the National 5 course. Maybe a few methods that you've seen, all slightly different, and this will give you a wee idea of how to approach. So if you have in number 1 a quadratic x squared plus 6x minus 5, when we complete the square, we're going to consider rewriting our x squared and x part of our quadratic. That means that within our quadratic, the minus 5 will not change at all. And we will look to write our x squared term within a bracket. So multiplying out that square bracket, x times x will give us our x squared term before. To be able to get the 6x, we take the 6x and we divide by 2 to give x plus 3 squared. Okay, so that x term here, we always divide by 2. What this gives us, if I multiply out my bracket x plus 3 squared, I will have x squared plus 3x plus 3x plus 9. Simplified, x squared plus 6x plus 9. As we see, that is very similar to our square red bracket. However, we have an additional plus 9 term where we have to correct ourselves by taking that away. So if I take away 9 within my working, that is getting rid of my plus 9 within my multiplied out bracket. So what I can say is that the two red square brackets in our first line and in our second line are equivalent. They're exactly the same. They're just written in two different ways. So simplifying, my overall completed square, x plus 3 squared minus 14 would be my completed square form. The part B, state the nature and coordinates of the turning point. This is one of the main reasons why we complete the square, because this form is particularly useful. We have a positive x squared term when we multiply out. So we can say that this particular quadratic will have a minimum turning point if we solve the bracket. X plus 3 equals 0, x is equal to minus 3. The minus 3 gives us the x coordinate, and we simply take our minus 14 for our y. So in our completed square form, we're quickly able to get our turning point. In example 2, again, I'm going to look to rewrite the first part involving our x squared and x terms. The plus 7 will not change. So in that particular form, I'll get my x squared by multiplying out my bracket, and if I've got minus 8x, I half that to get minus 4. Once again, let's have a wee look at that multiplied out. We have x squared minus 4x plus 16. So x squared minus 8x plus 16. So once again, our x squared minus 8x is very similar to our starting expression. What I have is an extra 16. So once again, I must take that off by taking my minus 4 and squaring it. So take away the square of the minus 4. That expression there, we have in our first line, the red brackets, my second line in the red brackets, both expressions inside are exactly the same. So multiplying out, so x minus 4 squared minus 16 plus 7 gives me minus 9. And once again, I have a positive x squared term. So I have a minimum turning point at, once again solve the bracket, 4 minus 9. And third example is slightly trickier because my coefficient of x is an odd number. Exact same approach. I'm going to rewrite my red bracket, which does not affect the 4 at all. To get my x squared, and in this case, I need to half the 5 term, and that's simply 5 over 2. And in this case, as the previous examples, I always take away this 5 over 2 squared. And in this case, if I go 5 over 2, and I'm looking to square, that's 25 over 4. Indices rule, square the top and square the bottom. Okay, so again, I'm confident, I've not multiplied out the brackets in this case, but I'm confident that my red bracket in my first line, my red bracket on my second line are exactly the same, just written in different forms. Every single time I've divided my x coefficient by 2, taken that down and taken away that value squared. Just out of neatness, I will rewrite (5 over 2 squared). I've taken away 25 over 4. There's 4 over 1. So I must add on times the bottom by 4 to get 4, and times the top by 4, which would be 16. So x plus 5 over 2, all squared, minus, I've got 25 fourths and I'm adding on 16 fourths. How many fourths have I got overall? I've got subtract 9. And that's my completed square form. Definitely complicated when I have my odd number. Once again, when that multiplies out, that x squared term will be positive. So I have a minimum turning point at, solve this bracket, so x must equal to negative 5 over 2. That is my x coordinate, and not forgetting the minus, that is my y coordinate. A few examples on completing the square.